So in continuation of our previous talk, now let us see ultrasonic, another way of ultrasonic generator, that is magnetostrictson method. We have already discussed piezoelectric method. Now magnetostrictson method. See, magnetostrictson means when a magnetic material is magnetized, in the process of magnetization, its length is changed, and also in the process of demagnetization, its length is slightly decreased. So this changing behavior of changing nature of length during the time of magnetization as well as demagnetization is said to be magnetostrictson. Okay, magnetostrictson. So in this method, ultrasonic waves can be generated. So for that, you need a magnetic rod. For example, here usually we use ferromagnetic material like iron, cobalt, and nickel. And initially, it will be permanently magnetized by means of applying DC current, and then this it is wound by coils like this. So it will form an inductor circuit L1 and L2. And there is a transistor, NPN transistor, which is a NPN transistor. This is base terminal of the transistor. Base terminal will be connected to one end of the inductor coil L2. Here, emitter is forward biased and collector is reverse biased. So this is the emitter, this is base terminal, and this one is collector terminal. So collector terminal is reverse biased. So it means there is a variable capacitor C1 and ammeter and base terminal. So the collector terminal is connected to another end of the inductor coil L. So this is the circuit, magnetostrictson circuit for the generation of ultrasonic waves. It is a LC oscillator circuit. The name of the circuit is LC. L stands for inductor. Two inductors are there, and C for variable capacitor. So it is LC oscillator circuit. So when initially it is a battery the transistor is energized by means of the battery, and in such a way current flows through the from a collector to the capacitor, and current starts to increase in the inductor coil initially. So when current starts to increase in the inductor coil L1, according to Faraday's law of induction, same magnitude of current but in different direction or in opposite direction will be induced. That is, EMF is electromotive force is induced in this coil L2. Keep in mind, at first current flows through this coil instantaneously. Induced EMF is generated here, and because of that, current flows in this coil, same magnitude of current flows but in opposite direction. And finally, current, the EMF will be sent to the transistor base as the input, and in this way transistor is being continuously operated. So this circuit, current electric flow of electric current is sustained in this circuit for unlimited time. For unlimited time. Okay. So because of this instantaneous operation and mutual inductance. Okay. So in this process, one can vary the frequency of this operation, frequency of this induced EMF by means of tuning the variable capacitor. So by means of tuning the variable capacitor, one can control the amount of current to be delivered to this coil or rate of current to be delivered to this coil, and in the same manner this coil induced EMF will be generated in the same rate. There is changing electrical signal will be generated, and because of these changing electrical signals, it is magnetized. These two ends are magnetized at different rates. That rate resembles the rate electrical changing electrical signal. So in this way, magnetization, because of changing electrical signal, magnetization takes place at different magnitudes as well as at different direction, and because of that magnetization, this ferromagnetic rod Fe undergoes magnetostriction, and that magnetostriction, because magnetostriction means stretching and compression. So always stretching and compression generates stretching and compression of materials generates, it may be air medium, it may be liquid medium, or it may be solid medium. It will generate ultrasonic waves. It will generate ultrasonic waves at the two ends of the ferromagnetic material. Usually this signal will be weak. This ultrasonic signal, emitted signal will be very weak. But we want high intensity, high energetic ultrasonic waves. In order to get high intensity, high energetic waves, we should increase the amplitude of this frequency of ultrasonic sound. High intensity ultrasonic sound. In order to generate high intensity ultrasonic sound waves, we should equalize the frequency of LC oscillator circuit. This LC oscillator circuit with that is, it should be matched with the frequency of the material magnetostriction. Frequency of magnetostriction. That it depends on the material's internal property like Young's modulus and its density. Okay, so it will vary for different materials. So one should match the LC oscillator LC frequency of LC oscillator with the frequency of the material's intrinsic magnetostriction frequency. So there is a formula. So the formula is I by 2 pi LC equal to 1 by 2L into square root of rho density n smallest divided by rho. So at this condition, it is possible to get high intensity. It is possible to generate high intensity ultrasonic waves. So by matching LC oscillator circuit frequency with the material's intrinsic magnetostriction nature, one can get high amplitude ultrasonic frequency signals. Here, L is the length of the ferromagnetic rod, and as you know, Y is Young's modulus of the material ion, and rho is the density of the material. As you know, L is the inductance, and C is the capacitance, and I is the current flowing through the ammeter. Usually, current will be maximum at resonance condition. So at resonance condition, current will be maximum, and so you will get very strong or high intensity or more powerful or maximum ultrasonic waves having maximum power can be generated. So this is how ultrasonic sound can be generated by means of magnetostriction effect and also by means of piezoelectric effect. Now we will see some of the applications of ultrasonic sound. See, basically, ultrasonic sound has an enormous number of applications, starting from medical industry to agricultural or any other military application part also it is useful. And in the case its main use is imaging. So in imaging means in the process of imaging any target you need to have a high resolution, because if we get high resolution, then only we can able to see the target samples very clearly. Okay, so there is a formula which from that formula you can easily understand the resolution of the image. Okay, that is percent reflectance equal to percent reflectance of ultrasonic sound is equal to rho suffix I minus rho suffix f divided by rho suffix I plus. Here rho I means density of the incident medium and rho suffix F is the density of the final medium where the target, that is the target, is located. Rho F means the density of the medium where a target is located. Okay. Suppose if the incident medium is air, you just imagine, and its density is rho suffix I, air, and it is solid. Here density difference between air and solid is difference is very high. Rho I minus rho F is very high. So in this case, since the densities are very high, most of the incident ultrasonic sound energy from air medium to solid medium will be reflected back. That is percent reflectance will be very high when this difference is very high. So percent reflectance is high means most of the ultrasonic waves are reflected back and only little amount of ultrasonic energy is passed through the target, and then if you recollect the target rays collect ultrasonic waves connected from the reflected from the target, it will definitely give poor images. So resolution will be low. Is low or low resolution. Suppose instead of a semi-solid like gel, a semi-solid like gel is used, or semi-solid or semi-liquid like gel, like mineral oil, kind of mineral oil is used. In this case, rosary side, human body. If you compare densities of these two mediums, one is mineral oil, another one is human body. Here, human body is like a semi-solid, very flexible semi-solid, and the gel is a semi-liquid. So densities are more or less equal. Okay, densities of these two mediums are more or less equal. So the difference, though rho service I minus rho service F is almost equal to 0, are very minimum, very small. So in this condition, most of the ultrasonic waves, ultrasonic sound energy will be passed from this medium to this medium, that is from gel to the human body. In this way, more ultrasonic sound is passed through the human body, and so the target place, it may be spleen, liver, or heart, or human brain, fetus. So the target image organ can be anything. Okay, so more ultrasonic waves pass through the target, and in this way you will get more reflected ultrasonic sound, which is reflected from the target sample. So in this way, resolution, you will get high resolution. Images of the target samples will be very high. So therefore we use a gel-like material, like mineral oil will be used before scanning, ultrasonic scanning. Gel-like material will be applied on the abdomen. In this way, you will get this condition, and this condition will be satisfied, and high resolution images of spleen, internal organs like spleen and liver, kidneys can be received. So based on this principle, one can get high resolution images of ultrasonic ultrasonic images of different organs using ultrasonic sound energy. Now I will conclude this lecture by telling some applications of ultrasonic waves. So starting from medical field, medical imaging. Medical imaging, that is, this ultrasonic sound energy is harmless to human body. If you take X-rays, they are very harmful. They can damage our eyesight and even sometimes brain neurals. But in the case of ultrasonic sound, it is not harmful. So therefore, for treating, for diagnosing, in the case of diagnosis of sensitive instruments like human brain and fetus, for collecting fetus image or fetus brain to know fetus brain abnormalities, you can use medical imaging. You can use ultrasonic energy. Okay. And secondly, so organs like fetus, spleen, liver, the images of the different organs like spleen, liver, and in order to identify any earlier stages of defects in fetus, all this information can be acquired by means of using ultrasonic energy. And secondly, there is a treatment called cavitron ultrasonic surgical aspirator. CUSA. So by means of this technique, cavitron ultrasonic surgical aspirator, a probe will be used, which is having at its output terminal, the ultrasonic sound will be generated, and this type of probe can be used to treat any brain tumors, in removing brain tumor. So when ultrasonic high energy ultrasonic waves around 22 to 23 kilohertz is incident on brain tumor, it will shatters the tumor, and the residues can be removed by means of using aspirator. Okay, so this is how brain tumor can be treated instead of open surgery. And third application is one can easily determine velocity of blood flowing in the artery. Blood velocity in arteries. So for that, ultrasonic sound will be sent to the arteries, and based on the speed of the speed of the blood in the inside the vessels, the reflected ultrasonic sound frequency will change. So by knowing, this is based on Doppler effect. So by knowing the incident frequency of incident ultrasonic wave and the frequency of the changing ultrasonic wave, one can easily calculate the value of blood velocity. Okay, blood velocity. So in the similar fashion, one can determine the traffic police can use ultrasonic sound to determine speed of the vehicle, fast moving vehicle, by sending ultrasonic sound, and by collecting the difference of ultrasonic frequency received. Okay? By comparing the difference of these frequencies and the time taken, one can easily determine the value of speed of the fast moving vehicle. So another application is ultrasonic ranging. So ultrasonic ranging means you can easily determine the distance between the source to the target. Suppose if you are having a night vision camera and integrate ultrasonic transceiver with a night vision camera, then you can easily, the transceiver sends ultrasonic waves, and when the target material reflects based on echo, when it reflects the incident ultrasonic waves, the reflected signal will be received by the ultrasonic transceiver, which is integrated with the camera, night vision camera. In this way, one can determine the distance between the night vision camera or the target source and from the target. So these type of night vision cameras are very useful, and in a drone application. So we can integrate these kind of night vision cameras with ultrasonic transceiver can be integrated with drones, quadcopter drones, and in this way one can easily identify the target distances. Momentarily, one can determine the target distances even at night time by sending ultrasonic signals and by collecting the reflected ultrasonic signals. So in all these cases, generally we use this equation, speed equal to lambda by frequency. So based on this equation, here lambda is wavelength, nu is frequency. So based on this equation, speed of blood velocity and ultrasonic ranging, that is the distance between the target and the source, all these things can be calculated. For all these things, this speed equation is the fundamental one. Okay, meet you in the next class.